Hi, Josh.
Hi.
Can you kindly solve the following problems? Number one, simplify this expression.
Okay. So the main concept we're going to be using is the fact that 2021 is equal to 2000 plus 21. So this will be
Yes.
very necessary. So if we let A equals 2000 and then B equals 21. So now we can express, so since 2021 is 2000 plus 21, this is also A plus B. So we can now express this big equation as A plus B, big expression, there's no equation. Minus A cubed minus
Okay.
and then now I will be showing the expansion of A plus B cubed. Will simplify this expression. As much as possible, we want to end up with only A and B. Oh, I will put this in different colors so it will be easier to see
Yes.
the expansion.
That's the beauty of technology, Josh.
Yes.
There you go.
And then
Perfect.
the bottom will just be simply AB times A plus B. So it will simply be A squared B plus AB squared. Okay. So if we can inspect, we can see these variables appear here. So we know something's got to do. Some of them they must be related in some way. In fact, they are because we can cancel this a cube, a cube, b cube, and then we are
So
left
left with
with 3a squared b plus 3ab squared 2 squared b plus ab squared. So these were the variables I was talking about, and in fact, they are the same. So we can factor it out,
factor out three.
3, and then we can actually see what's going to happen. I'm going to cancel the, this polynomial, this expression, not a polynomial. So we just simply end up with 3. This is the final answer. Such a big fraction just ends up with 3.
Yes, I think that's correct.
Yes. Now the next problem. When multiplied out, 15 factorial is equal to 1, that is 1,307,307,000,000
And, well,
670 something.
in short, one of the digits is uh, an unknown,
We
which is
have
A.
to find that unknown.
Yes.
So to start, we are going to express whatever 15 factorial is. And now I am going to be multiplying and showing, I'm multiplying with this that's bigger. I'm going to show the entire expansion because it is important so we can see
The
a
concept,
special
the concept behind your solution.
long. So I want to highlight one special number in this expansion, and that is 9. So 9 is very special. That's because every also that's not 9 is not really very special because it also has a cousin 3, which also has the same property. But for 9 and also for 3, but mainly for 9, all of its multiples have a digit sum of another multiple of 9. So if
Meaning,
we can express this like this: digit sum. I'll just use the more concise notation. Digit sum of x when 9 divides x. It's also oh also we must say this explicitly, or there might be confusions. X is an integer, and this equals some y, where y is, I put the spacing wrong, where y is divisible by 9. So this is a fun concept because we are given with all of we are given with all of the digits except a. So we can simply add all of the digits. Would train with zeros because they won't do anything to the sum. So eventually we are left with a plus 41. So with the given theorem, we can say that a plus 41 I needed to space a plus 41.
what do you mean by that notation? 9
9 divides
divides
a plus
a
41.
plus 41, or a plus 41 is divisible by 9, meaning when you divide a plus 41 by 9, there will be
No remainder.
no remainder.
And in this next the another alternate notation, albeit a little more complicated. Uh, we can see exactly that it has no remainder. The modulo function simply means that a plus 41 when divided by 9 has 0 as a remainder, essentially having no remainder.
No remainder.
So now we can go back to our solution. So we are looking for a number a that is a digit. This means a is less than 10 but still greater than or equal to 0. And finally, this sum has to be, of course, greater than 41 because it's an integer. Or actually, it can be equal because we don't know what if a is 0 or
Could be
not.
0.
So the closest multiple of 9 that we can think of is 45. So this would instantly make a equals 4. But what if a plus 41 is the next integer? The next multiple of 9, which is 54. Then this would make a equals 13, which is not a digit. It has 2 digits. So this cannot be.
Yes.
This is our answer. Then using the same concept, we can make a simpler technique of deducing a. Let's see, we have the digits 7, 8, 6, 8, 0, 0, 0. Since the zeros do nothing to the sum, cancel them. And then we can cancel out pairs that add up to 9 because
1 and 8, yes.
it's 1 and 8, 6 and 3, and 3 and 6. Do we have any others? No. So we are left with 7, 7, 8.
Yes.
Oh, I have to separate them with my I think it's 778. Okay, 778. So we instead of having to do a plus 41 is some the nearest multiple of 9, we can just simply do 14 plus a.
Oh, where did you get
Um,
14? You show them.
7 plus 7 plus 8 equals 14 plus a. Is what's the closest integer for
Which is
14
supposed
plus
to be
a?
what first?
Oh, this is supposed to be a multiple of 9.
Yeah. Can you
See.
for our viewers, why or parenthesis multiple of 9, so that for those who are not familiar with your notation, yes.
Oh, there might be some confusion with the might be multiplication. Over here, good. So the closest multiple of 9 to 14 is 18. So again, a will be equal to 4, but let's say it were equal to 27.
The next multiple of
Then
9.
a will be equal to 13, which is again like here in the same using the same logic. It has 2 digits, so it obviously cannot
It
be
can
a single digit.
can I substitute for a, which is a is supposed to be just a single digit. Yes.
Okay, so again, we are left with a equals 4.
Yes.
So a equals 4 is really the correct answer. If you really want some epic proof, you can calculate a 15 factorial, and even on just your calculator, you can still see that a is indeed equal to 4.
Yes.
So,
we go to number 3.
number 3, this appears to be a very hard question
Yes.
immediately because it appears like it is a hard sextic problem. It even has a cubic in it. So it's not the first sextic. And it turns out this one, the easiest sextics, is called the triquadratic equation. So in order to solve this, let a unit, short for unit, is equal to x cubed. Then we can reduce x to the 6 and x cubed into, oh, I almost wrote u squared minus 9 u plus 8 equals 0. Yay! So we have a very simple quadratic equation. So we can approach this by using the quadratic formula. Quadratic formula.
For your viewers, you just substitute first the
Oh,
intermediate before you became like this. U squared is x squared x cubed raised to the power of 2, right?
yes.
Can you write it there for your viewers?
Wait, I need the space. I need to move this a little here. Oh no.
No, no, just on the side. So,
We'll put it here. Really doesn't want to be moved. Okay. So, 2 squared minus 9.
okay.
Okay, so quadratic formula. For any x squared, ax squared actually, ax squared plus bx plus c equals 0. We have the following formula. X is equal to negative b plus minus the square root of b squared minus 4ac, which is also known as discriminant. And on the bottom is 2. So we can substitute. There's a hidden ones. Is there A, B, C? Direct substitution. So go back to my blue ink. Negative 9 plus minus Then the long denominator, long fraction bar, just multiply.
What are you looking for there?
We are looking
Is it a
for, oh, okay.
you're right.
We are still not at x because we let u equals x cubed. So 1. Simplification. Mm, 9 plus minus square root of whatever 81 minus 32 is. So 81 minus 32 is just 49.
Mine, yes.
Oh, the zoom corrected my sharp edges. That's rare. So 9 plus minus 7 over 2. So 9 plus minus 7 is this is either 16
No,
or 2.
just write the two
Okay.
into equations so that those who are trying to learn will be able to follow. Anyway, you can use other pages. U is equal to, what is that? Always,
U is equal to
you're right. So those for the viewers.
U. 1. And then u is again x cubed. So to get x, we need to cube root 4. Let's say we
You
assign
substitute the,
1.
you substitute the, what is U there?
Yes, wait. So x is equal to cube root of u. So for u1, okay, for x1, we need u1. So that's the cube root of 8, which is 2.
Okay.
And then for x2, we will use the cube root of u2, which is cube root of 1, which is 1.
Yes.
I will just make another page. The next page is occupied already. Okay, so there's another way, an easier way. So we are.
So your original equation is x to the 6 minus 9x cubed plus 8 equals 0. So how else can you solve for that, for x there?
Instead of treating it as a triquadratic equation, we can just treat it as a normal sextic equation. But it's easier because we can simply factor it. We're going to use the factoring method.
Yes, so the very fact is the expression on the left side is factorable.
In fact, it's very easy to factor. So now, let's say
Zero.
giving this is 0, this is 0. We get
No, you're right. Josh, no. Don't do that, don't do that. For your viewers, use the proper notations.
x cubed.
Don't do the shortcuts so they can easily follow your solution. Yes. And here you should have shown don't assume that all your viewers are good, very good mathematicians. That's why they're watching, because they're not just curiously because they want to learn.
Okay. So x equals 1 or 2.
Yes. So let's correct. So you gave two alternate solutions. One alternate solution. So which is a lot simpler. Just simply factor the expression on the left side.
So this is ABC, different digits. ABC, letters ABC represent different digits. Actually, we don't just put the represent a number using letters because they can be confused with variables. Put an underline and what below. So the letters ABC represent different digits. Different digits. A is prime and A minus B is equal to 4. If the 7-digit number
BB is prime. Find the ordered triple ABC.
So there are only two primes, which is 5 and 7 on using block.
Yes, you can use a different color.
There are only two primes, 5 and 7. When subtracted, when you subtract 4, they give us with a digit, which is just a one-digit number. Because the next one will become.
Let me check the. You explain, Josh.
So, as I was going to say, 11 minus 4 is equal to 7. That's a digit, but 11 itself is not a digit, so it can't be substituted for A. And 3 minus 4 is negative 1, which is obviously negative. It's not a digit, so you can't substitute it for B. No, for, you can't, yes, you can substitute it for B. So, we have only two choices for A and B. One is 5, 5, 5, 1, 1, 1, something, which is C. And then the other one is 7, 7, 7, 3, 3, 3, C, something. So it will be a little hard if we do it on our own. So the closest prime using a digit as C, there's only one prime that can fit this, and that is 5, 5, 5, 1, 1, 1, 1, 2, 4. This is the only prime that exists with C as a digit. And then for the second one,
You can use red for C, so your viewers will be able to follow your solution easier.
there also exists one prime in this world that has a digit for C and still prime. So both of these are primes, but only one of them is the answer because in here,
Right there, 5, 5,
C
5 is prime.
one
Right.
prime. Prime. Here C is 1 and simultaneously B is also 1. But we can see in the problem that A, B, and C represent different digits. So this solution is wrong. Whereas here, they are all different digits. We can't see any possible infringement. So
Just pick up the mark.
A equals 7, B equals 3, and finally C equals 1. This is our answer.
Yes. Nice.
For those wondering where you can find how do we know if these are prime? There are multiple catalogs that give us the list of prime.
Careful.
Five. problem for 5 appears to have been deleted. Right?
Okay.
Since the Zoom deleted the logs.
Excuse me. Right. Uh, the expressions I've used a different color. A times B, A over B, A plus B, and A minus B, which represent a real number. And three of them are equal.
There's an imposter.
Oh, yes. Only three of them are equal. So find the all possible or ordered pairs. A, B, A, for which this is true. Okay,
So
you can use like a different color.
this is a very interesting problem. So let's because I know we're by trial and error, and it seems that plus and minus are easier sort of operations. Let's roll the dice. Let's see what happens if we assume a plus b is equal to a minus b.
Put there if assuming or let's just put assume.
Actually, assume
Put there assume.
Assume goes throughout that goes up to the entire proof, but if you put if it will signify casework. So if a plus b is equal to a minus b, we can move the a and then we can move the b too. So eventually,
Show us. For the
yes.
viewers don't expect that they are very good all of your viewers are very good mathematicians.
So I was just about to show b is equal to 0, which is impossible. Why? Because a over b is equal to a over 0.
If B is 0, then
Equals 0, which
A
is
over B.
undefined. So it says here each represent a real number.
Okay.
So this entire case, this is a highlighter, is wrong.
Okay. Let's leave it there as a proof, right?
Yes. So we must
keep track of the charge
say
of our computer.
still good. So we can now say a plus b is not equal to a minus b. But actually, just from the fact that we found this means that if a and b cannot be equal to a minus b, there are only two possibilities for which three equations are equal. So these are the possibilities. And then ab is equal to a over b is equal to a plus b, but b excludes a minus b. And the other one is ab is equal to a over b is equal to a minus b. But this time we exclude a plus b.
Yes,
because these are not equal.
Yes.
Okay, so let's try the first case. Actually, we can try both cases. We just have to cut off this equal to a plus b or equal to a minus b. Let's
Yes.
just use ab equals a over b. So this is obvious because even for both of the cases, this must be true. So this statement is true.
So show us.
So
Can you use different colors with yes.
we can you're so inclined. I will show times b times b. We'll cancel. And then we can end up with
Everything.
ab squared equals a. And then now, ab squared minus a equals 0. So we transpose to a. And then factoring out a, we end up with a times quantity b squared minus 1 equals 0. And although we cannot see it right away, like a quadratic, the solution for a quadratic equation, when you factor it, either a is equal to 0 or b squared minus 1 is equal to 0. So for a equals 0, we leave it as is. And then for b squared minus 1,
B will be
b squared is equal to 1. Therefore, b is equal to plus minus 1. So we have two choices. Either b is equal to 1 or negative 1. So now, we are in a much complicated situation. We have now three cases, not just two cases. So now,
which we need to explore each, right?
we need to explore each situation. What if it turns out there's actually one situation that we have overlooked? So for the first case, if a equals 0, I'll just underline our first case. Okay. So here earlier, for the other problem. Here earlier, we can see that AB is equal to A over B equal to A plus B. For this one, we can say AB is equal to A plus B. And for here, AB is equal to A minus B. We're going to use those. So if A equals 0, for the first case, what happens if AB is equal to A plus B? We're narrowing down which three of the expressions are equal. So when AB equals A plus B, we can
While you're solving, I'll just let the chart.
eliminate. B equals 0. Again, for B equals 0, we saw earlier, B is 0 is impossible. I'll just put the y that happens because A over B is equal to A over 0. In this case,
the page, they might get
it
confused
is
with
undefined.
this. Don't rush too much.
So this is an impossibility. Then for the second case, when A equals 0. Oh, I forgot. You have to be careful when using your terms. Assume is different from if, different from when, different from case 1 or case 2. So for 2, I'm going to see if the next one will work. What happens when AB is equal to A minus B instead of A plus B? So this time we end up with the same thing. 0, 0, B equals minus B. Well, almost the same situation because we end up with negative B equals 0 and again B equals 0, which we already proved is undefined.
Yes.
So this is again an impossible case. So what does this mean? No. I'll just move on to the next case we accumulated from earlier. Oops, the wrong page. So our next case is when B is spread this out. So it's easier to see which case. B is equal to 1 or B is equal to negative 1.
Check the slide. Okay, still some.
1, negative 1. So maybe the intuitive thing to do is when B equals 1 first. When B equals 1. The puzzled. Okay, so when B equals 1, we have our first case again. I'll put the second case too here. So when we check the first case out, we see A times 1, 1 equals A plus 1. So we see A is equal to A plus 1. And this is not just the maybe you could be thinking why this is impossible, but the very nature of numbers proves this is wrong. This is very impossible.
Because A is equal to A only. So A plus 1 is what?
A plus 1 is a different number already.
Yes, it's not equal. It's not the same as A.
So now maybe you're also thinking what happens here. I'm pretty sure you already know that this will also end up with a very impossible case again. We just switch signs. Now it is claiming that A is equal to A minus 1. And earlier we just saw that A cannot be equal to A plus 1. This is also A minus 1 is also a different number.
Yes, A is definitely not. Can you
This is
put the not
definitely
equal there?
not. I'll put a red because maybe
Yes, red. Yes.
A is
Okay.
definitely not. So we have another case when B is equal to negative 1.
So
1. I'm assuming it will take the same amount of space. So B equals
A plus B minus B.
equals to 1 minus 1
The equal sign.
equal sign is conjoined. There. The A minus 1, but this time this is
Times negative 1. Huh?
negative 1. Yes, I will find that out. But this time it appears it's actually a solvable equation because we can move A to the other side to become 2A minus 1. Then 1 equals 2A. A equals 1 half. Okay, we got something. We got something out of it. The fact that
Yes.
now we'll forget the negative sign. This is equal to A plus 1. And again, this looks solvable. Here equals 2A plus 1, and then so negative 1 is equal to 2A. So A is equal to negative 1 half.
Yes.
So maybe to make it a little clearer, Okay. It's very
Summarize
summarize so we can see the solutions clear instead of just stating them where they are on the tables. We make a short table. So when A is equal to 1/2 and then B is equal to negative 1.
can we check the charge of the laptop please? Also good.
A is equal to negative 1/2. B is still equal to negative 1.
Black. Three subdivisions is black.
Okay. Make it very tactile.
Red.
I will make 4 divisions for our expressions. Each of them.
Oh, sorry.
So, our short table. Now, oh, I'm still in line 2. For AB, this is negative 1/2, then negative 1/2 again, negative 1/2 again, but this time finally is 3/2. Okay, and then this it is positive 1/2. I'm emphasizing the positive on this. This time is negative 3/2, and then this one is positive 1. I'll just put a tiny subdivision. Then put the chips.
Perhaps you can color, you can highlight the same with
The same results.
same results.
It's,
Yes, those three are equal.
and then
When A is 1/2 and B is negative 1.
note that only B equals negative 1
B negative 1.
prevails. So, oh wait, I colored the wrong one.
Can you fix the B? It's like
There's a tiny hole in it.
yes.
Okay, so we didn't end up with just one, but 2 ordered pairs. So to summarize, we have these ordered pairs A, B, negative 1/2, negative 1. This is our final answer.
Nice. That's good. Nice time.
So I hope you learned a lot from this video.
Yes,
Thanks for
and
and
share. Don't forget to share and subscribe.
hit that like button.
Hit the
And,
like button and the
that
bell
notification
so
bell.
that you can see the next videos of Joshua.
All right. So
Goodbye.
goodbye. Bye bye.